Greetings everyone. Introducing myself, my name is M. Devendran, and alongside Dr. Rashid Samsudin and Muhammad Hakimi, we'll be presenting on our invention, the Solar Integrated Anaerobic Digester and Aerobic Composter, otherwise known as SIDAC. I'll be starting off with the motivation behind SIDAC. Did you know chicken meat is the second most staple food item in Malaysia after rice? This has resulted in the production of chicken manure in abundance. Raw manure is often utilized as organic fertilizer. However, this practice observes significantly detrimental effects on the environment. Another industry that has been thriving is the palm oil industry, as Malaysia remains the second largest palm oil producer worldwide behind Indonesia, producing a lot of biomass waste, one of which is empty fruit bunch, otherwise known as EFB. EFB is oftentimes underutilized. It is normally used as fuel for boilers in power plants. However, due to its high moisture content, it lowers the combustion temperature, effectively reducing the energy efficiency. Now, what if I tell you it's possible to take the waste from these two industries and generate something value added from there? Through SIDAC, we're able to incorporate anaerobic digestion and aerobic composting in a single unit to produce biogas and biofertilizer, which is beneficial for the society. Also, SIDAC incorporates solar energy harness, which is aligned with the 12th Malaysia Plan for the nation to be carbon neutral by the year 2025, shifting the focus to renewables, especially biogas, biomass, and solar energy generation. However, as any scientific invention goes, there are a few technical and operational constraints. One of the technical constraints is that neither chicken manure nor EFB meets the desirable carbon to nitrogen composition required for the process. Also, EFB is rich in lignin, making it naturally recalcitrant to microbial degradation. There are also a few operational constraints, one of which is that the process requires a technically competent person to constantly monitor it. It's also a challenge to upscale or modify a lab-scale unit, and it's an even greater challenge to come up with an all-in-one unit. However, fret not, with SIDAC, we're able to recognize and address these concerns. SIDAC is a modular unit, which is directly scalable via serial connection. It is also cost-effective, as its feedstock is essentially waste, and it incorporates solar energy harness, which means that it focuses on hybrid energy utilization. SIDAC also requires minimal technical know-how to operate, which adds to its cost-saving attribute. SIDAC is a 3-in-1 unit, which means that treatment, storage, and utilization features are all incorporated in one unit.
Over here, what we have a 20-foot container unit where it serves as treatment unit for organic waste, and while you treat the organic waste, we produce biogas as well as biofertilizer in the form of compost. So what it does is you have a pre-treatment unit where we formulate the process according to our own patented formulation, and after we condition that into our specific formulation, we're going to pump that into 2 stage of anaerobic digester unit. So while we do so, we're going to generate biogas, and this biogas is going to be purified to remove contaminants so that we can have a high purity methane concentration in the biogas, and that methane is good for heating, such as for cooking, as well as can be converted into electricity. And this electricity going to power up the battery of the system together with the solar panel that we have installed for the unit. And for the digestate, which is the solid remain, we can further upgrade that into compost using our technology where we can customize the NPK content of the compost product. And this, together with the ability to treat the organic waste, can support various sustainable goals as outlined by United Nations as well as the government of Malaysia. Alright, as we condition the pre-stock according to our formulation, we will pump the feedstock into the first anaerobic digestion tank, or AD tank number 1, where we continuously going to feed the tank with our feedstock, and it will accumulate in there, and to certain time it will overflow into the AD tank number 2, and the process continues while we feed both of the tanks with our feedstock. We're going to generate biogas, and this biogas will be channeled to the biogas bag at the top of the unit for collection purpose. And this biogas will go through the two-stage purification system to remove contaminants such as CO2, H2S and others, and including moisture as well. This methane can be used directly for heating, which we have the stove on site, as well as the electricity using a generator, whereby we can convert directly methane straight away into electricity, and this electricity can power up the battery of this unit. And while doing so, we can reduce the dependency of this unit from power grid of the PNB. So we can have this unit as a standalone off-grid unit for organic waste treatment.
Moving on with the results and discussion. As you can see, biogas and biomethane generation has been increasing steadily throughout the rotation time of 50 days, and the highest cumulative methane composition was obtained at 72.5%. Fly test has been done to compare the fly elevation potential between feedstock and digestate. Through anaerobic digestion, the flies attracted towards the digestate decreases significantly.
There are also a few cost-saving attributes and commercialization points. One of the cost-saving attributes is that poultry and palm oil industries need not pay penalty charges for improper disposal of chicken manure and EFB, as they can be used for feedstock to the operations of SIDAC. One of the commercialization points would be production of safe organic biofertilizer, as the digested slurry at the end of the operations of SIDAC can actually be sold as a form of biofertilizer, and there will certainly be a market for this as it's significantly cheaper compared to urea. Another commercialization point would be electricity generation. Should we upscale the system to cater to 1,000 tons of feedstock, it can generate electricity up to 271,210 kilowatt-hour, which can conveniently provide electricity supply to more than 65 medium-income Malaysian households for up to 1 year, producing an electricity sale of up to 78,772 ringgit Malaysia.
Moving on with the impacts of SIDAC. The impacts of SIDAC can be divided into society, industry, environment, academia, and government. To summarize the impacts that we have, SIDAC can create more job opportunities, it is self-sustainable, it can reduce greenhouse gas effects, and lastly, it supports multiple sustainable development goals. Moving on with the fourth industrial revolution. So SIDAC are equipped with pH and temperature sensors for monitoring purpose. In terms of safety, SIDAC also has a safety release valve attached to a biogas bag and gas sensors to detect leakage. Lastly, SIDAC has also a gas flow meter for us to monitor the volume of biogas daily. So in the future, all of these activities such as monitoring the pH and temperature, monitoring the safety, and monitoring the volume of biogas can be integrated and can be put into mobile apps, into a mobile, so that we can monitor these activities remotely. Moving on with the next slide. So for the conclusion, SIDAC capitalizes on biogas, biomass, and solar energy for green energy generation, reducing dependency on fossil fuels. SIDAC also offers an easy solution to the technical and operational constraint of anaerobic digestion while being cost effective at the same time. With that, thank you.